Hello. Not everyone in the hobby, particularly those who just started, know what the phrase arc minute, arc seconds, or degrees mean. And when they see the size of an object in their atlas or on Stellarium or somewhere, it says 100,000 light years in diameter, they think, oh, okay, I know how big that is. But if they see two objects the same size, and one is a lot closer than the other one, it looks a lot larger. Uh, that's why they have an alternative way of sizing things, which is apparent size or apparent diameter. What they do is they break a circle, the sky, up into 360 degrees. Each degree has 60 arc minutes or minutes, and each minute has 60 arc seconds or seconds. And when they say that something has a 30 arc minute apparent size, they're looking at the angular size to it. This allows you to compare things that you're seeing to figure out, is that looking larger than this? However, without something to compare it to, a known size, is sometimes difficult to figure how big is 15 arc minutes, or 15 degrees, or whatever. So I'm going to show some things here using the moon as a guide. Now the moon is 30 arc minutes, 1/2 degree in diameter. Knowing that, you can compare the size of other things to the moon. So if something is 15 arc minutes in diameter, it will appear half as large as the full moon. The sun, interestingly, is the same size as the moon as far as the apparent size. That's why when they have an eclipse, the moon blocks out the sun. Now the moon's receding about 2 inches a year. That's why 100 million years ago, when you had a solar eclipse, you couldn't see the corona. The moon was closer, so it blocked out more. 100 million years from now, it'll be farther away, so when you get a solar eclipse, it won't block out much of the sun. I've listed some, I've taken some photographs, and I took the moon, a photograph I took of the moon, and resized it so that the object that in the photograph and the moon are next to each other, and you can see how big they are compared to the moon. And the moon is 30 arc minutes, so if something is half as big as the moon, it's 15 arc minutes. I have here Major 1, Crab Nebula. It's 7 arc minutes by 4.8 arc minutes. It's not round, it's kind of squarish. It's smaller than the moon. Here's M13. At 20 arc minutes, it's about 2/3 as big as the moon, as far as the apparent size. Here's M32, Triangulum Galaxy. It's 8.7 minutes by 6.5. So it's a little smaller than the moon as well. Here's M27, the Dumbbell Nebula. It's about the same size, the same apparent size as M32. It's 8 arc minutes by 5.6 arc minutes. A little smaller, but not much. Here's M31. Now it's 3.1 degrees by 1 degree, which make it a lot bigger than the moon. If you put the moon and Andromeda Galaxy right next to each other and had cat's eyes so you could see Andromeda Galaxy, the whole thing real clear, it would be about 6 times as large as the moon. It's one of the biggest things in the sky. Here's NGC 7000, North American Nebula. It's 120 minutes by 100. So it's about about 4 times the size of the moon. And here's NGC 7293, and it's 25 arc minutes, which make it a little smaller than the moon. So comparing these, you can look on my shorts or in Stellarium or wherever you see the relative size, apparent size shown. You can think in your head, well, that's 60 arc minutes, so it'll look about twice as big as the full moon looks. Yeah, or at least that's the way I do it. You might have some other way of comparing the things. So that's all I have for right now. Till I see you again, happy trails.